All right, guys, so today we are continuing our notes for graphing systems of equations. Today we're going to go over different cases of systems of equations where we may have a different number of solutions than what we have been practicing. So far, every system of equation we've gone over has had one solution because when we graph it, we see it intersect one time, but that's not always going to be the case. So let's look at our first example. We have y equals negative 1 over 4x minus 4 and y equals 5 over 4x plus 2. So starting with my first equation, we're going to do exactly what we've been doing, which is identify our y-intercept. Our y-intercept here is negative 4. So I'm going to go ahead and plot negative 4 on the y-axis. That's going to be my first point. Then the slope is negative 1 over 4. And so I'm going to use my slope to find my remaining points. Negative 1 tells me that I'm going to go down 1. And the 4 on the bottom tells me that we're going to go to the right 4. So I'm going to go down 1 to the right 4. That's my next point. I'm out of space here. I can estimate the next one, or I can go in the reverse order. So I'm going to do that. Instead of down 1, I'm going to go up 1. Instead of to the right, I'm going to go to the left. 1, 2, 3, 4. And once I have enough points to create a nice long line, I'm going to go ahead and connect them to do that, to create my line, just like that. Okay. I'm going to repeat the same thing for my second equation, which is y equals 5 over 4x plus 2. B is equal to 2. And if you don't know how we're getting these numbers, remember slope-intercept form is y equals mx plus b. Whatever replaces the b is your y-intercept. So in this case, b equals 2. Whatever replaces your slope is, whatever replaces m is your slope. So in this case, our slope is 5 over 4. Okay, so we begin at 2. So I'm going to plot my point at 2. And then my slope of 5 over 4 tells me we're going to go up 5 and to the right 4. So beginning at 2, we're going to go up 5, 1, 2, 3, 4, 5, to the right 4, 1, 2, 3, 4. And I'm out of space here, so I'm going to go in the reverse order. Instead of up, I'm going to go down. 1, 2, 3, 4, 5. Instead of to the right, we're going to go to the left. 1, 2, 3, 4. And we can see that that's where they're intersecting. So let's go ahead and connect the points. That's super important. Don't forget to connect your points to create your line. And this is the point of intersection. So in this case, my solution here is going to be negative 4 because I can see that it's at negative 4 on the x-axis and negative 3 on the y-axis. So my solution is negative 4, negative 3. So when my lines cross one time, and that means that we have one solution. There is one solution because my lines intersect just one time. Whoops. All right. Let's look at the next example. Next example, we have y equals x plus 5, y equals x minus 2. So doing the same thing, figure out what your b, which is your y-intercept, what that is. In this case, our b is equal to 5. So my first point is going to be at 5 on the y-axis. Our slope is equal to 1 because remember, we have an invisible 1 here. But 1 is the same thing as 1 over 1. We want it to be a fraction so that we can find our points. So our 1 on top tells us to go up 1. The 1 on the bottom tells us to go to the right 1. So we're going to go up 1, right 1, up 1, right 1. And I'm going to reverse the order to get more points. Down 1, left 1, down 1, left 1. And I'm happy with those. So we're going to go ahead and connect them to create our line. Just like that. Okay, we're going to repeat the same thing for the next line, which is y equals x minus 2. In this case, b equals negative 2. And m again equals 1. And so 1 is the same thing as 1 over 1. So we're going to go up 1, right 1, beginning at negative 2, up 1, right 1, up 1, right 1, up 1, right 1. Okay, and once I create my line, I'm going to look and see where they intersect. And if you could imagine these lines going on forever and ever and ever, do you think that these lines are ever going to intersect? The answer is no. And so because they will never intersect, they go on forever and ever, and they will never ever cross, then there's going to be no solution. So we would say there's no solution because the lines never intersect. So this means they don't have any points in common, any solutions in common. And so notice how with no solution, we will always get no solution when the slope is the same slope, but the y-intercept is different. So that's going to be a huge hint. Anytime I have a different y-intercept, but the slope is the same, then that means that we will have no solution. Without even graphing it, you would be able to say that you have no solution. All right. The final example that we have is y equals negative 2 over 4x plus 2, y equals negative 1 over 2x plus 4. So again, identify b, which is 2 here. I'm going to go ahead and plot that on the y-axis. b equals 2 is right there. Our slope is negative 2 over 4. So negative 2 on top tells us that we're going down 2. The 4 on the bottom tells us we're going to the right 4. So beginning at 2, we're going to go down 2 to the right 4. 2, 3, 4. And I'm going to go in the reverse order, up 2 to the left 4. 1, 2, 3, 4. And I'm going to go ahead and create my line. Right there. So my line looks like that. I'm going to repeat with the next equation, y equals negative 1 over 2x plus 2. In this case, b equals 2. And so I'm going to go ahead and plot 2. And notice how that lands on a point that I already plotted. The next step is to identify our slope, which is negative 1 over 2. Okay, so negative 1 tells us to go down 1. 2 tells us to go right 2. So down 1, right 2. Down 1, right 2. Down 1, right 2. And so notice how every point that I just graphed lands on that same line. And so remember, both of these lines go on forever and ever. So that blue line intersects that red line at every single point. Infinitely many points. And so in this case, we would say that there are infinitely many solutions. Because the lines overlap. They cross everywhere. It's the same line. Okay, and so a hint here is that if we have the same y-intercept and the same slope, then we will have infinitely many solutions. And so if you look at the slope, it doesn't look the same, right? But the reason why it doesn't look the same is because one of them, this one here, is not simplified. We could simplify this by dividing by 2 on top and bottom, and you would see that negative 2 over 4 is equivalent to negative 1 over 2. They're the same thing, just written in different ways. So there you have it. So we have 3 different cases that we're looking at for number of solutions. We have infinitely many solutions, no solutions, or one solution. Okay, so we'll get some more practice with determining how many solutions the systems have. So make sure that you ask any questions if you got stuck anywhere, and we will continue to practice. All right, guys, have a good day.